Okay guys, what we have here is a 30-pound propane tank that's been cleaned up, so it looks halfway decent, so it doesn't really resemble a propane tank, but at any rate, what we do here through this T fitting is inject our air into here, which in turn fills the air receiver, which also fills this tube, which fills the backside of the shuttle valve piston, which we'll show you momentarily. Moving down, what we did was we just took a national pipe fitting and welded it to the propane cylinder. And this coupler here is actually national pipe over on this side, and this is a -32 thread. It's an ORB fitting due in part to this valve. This shuttle valve came off of a halon fire extinguishing system. Pretty burly. We've got a gauge on here that'll monitor the receiver pressure. Moving on here, straight up national pipe from here on out, union to detach the water cylinder, and this is a 50-pound condemned CO2 cylinder that we picked up from Universal Cylinder in Salt Lake. 15 bucks, can't beat it. We cut the bottom of the tank off. It's plated off right now with a rubber gasket. In the future we will put a check valve on there for the mere fact this is going to sit submerged in a pool, and it will autonomously be able to fill itself with water. Moving on up, we cut the top of the tank off and we welded a national pipe fitting in here, 2-inch national pipe. We've also experimented with a few knife edge valves that basically screw on there. They're just cast iron caps, pretty simple, spun on a lathe with different diameters, although we've had pretty good success running it wide open. Okay, let's move back down to the valve. Okay, once again, this air line pressurizes the backside of a piston. This here is a dump valve that is attached to the backside of the piston as well, in the backside of the chamber. This is wired to a 12-volt battery, which has a normally open momentary switch. As soon as we hit the switch, it opens this solenoid valve, which in turn dumps all the air out of the backside of the piston. Let me go ahead and take this apart. Okay, you can see the opening there to the dump valve, and this is an ORB fitting as well. And this air line is actually ported through a port that actually exits right there through that hole, which in turn pressurizes this cavity. I'll go ahead and pull this piston out. Pretty stout unit. How this works is we've got 90 psi on the backside of this piston and 90 psi on the front side inside the air receiver. Since the air receiver diameter, this diameter here, is smaller than this diameter, this one always wins. Therefore it pushes this shuttle valve from that side up against there, blocking that port. When we dump that air off the backside of this chamber, which dumps the air off the backside of the piston, this piston slams this direction, in turn connecting these two ports, in turn going into the water cylinder, and out water goes. Okay, we'll go ahead and put this back together and we'll recap. Okay, starting over here at the air receiver, I probably don't need to tell you guys where to get a propane tank. Pretty self-explanatory that way. It's all national pipe fitting up here. This is pretty straight up stuff, compression fittings and whatnot. Standard air connector here. Okay, down here This you're better served to get at a hydraulic company. There again, if you pick up one of these valves, you're going to need that. That's the critical part right there, that hex, and of course weld them together. This valve, what I would suggest is calling a fire extinguishing company or a fire suppression company. See if they have any old takeout halon tanks with valves laying around. A lot of guys will just send them off to the scrapper, and that's kind of a shame because that's a really cool valve. The rest, pretty straight up. This here, this condemned tank, if you're interested in that, what I would do is call around in your local area to guys that certify tanks, welding tanks, scuba tanks, so on and so forth. There again, these guys, if this particular tank failed because it had a little pit at the top of it from an arc flash. Perfectly good tank, so long as you don't put it under pressure, which obviously we're not putting it under near any pressure. There again, get a hold of a company that tests cylinders. You'll be in good shape. Everything else, Home Depot or Lowe's or any hardware store can get you taken care of. You will probably need access to a small lathe to do a few of these parts, and preferably a TIG welder. Beyond that, we'll go ahead and stop the video and we'll load it up, show you how it's loaded up. We'll get it all pressurized and we'll shoot this thing off. Okay, since we've got to fill it up manually, that's what we're doing right now. We're just filling the water tank, and that piston valve is actually shut, so it doesn't bleed into the reservoir. We'll be set up here just a sec. Try to stabilize this camera a little bit. Okay, it looks like we're all set there. Just going to go ahead and plug the air into the air receiver. It's going to charge up that tank. We're ready to go. Yeah, it's probably about 150 to 170 feet up in the air, 2-inch solid stream of water. We kind of consider it a success. Go ahead and fill it up one more time. I'll pause the tape. Okay, back for shot number 2. Alright, I'll go ahead and pause the tape. We'll do another shot, and I'll get a little closer up on the water stream. Alright, we'll do a close-up shot here. Okay guys, I'm about 50-60 yards away from it right now, just to give you a perspective of how high this thing will shoot. Okay, I'll back it all the way out. There again, I'm about 60 yards back